We're moving to the next group. It's WeldWise, AI Adaptive Welding System, right? Please go ahead.
All right, hello, we're Team Inforex, and did you know that about 500,000 people gets injured every single year from performing welding job? On top of that, about 1 billion get wasted on scrap material, incorrect welding. There is a 40% welder shortage projected to be by 20-30%. So the industry right now is facing a lot of the problems. The safety concerns is that there are a lot of regulations that prevent some of the injuries, but the nature of the job is just really hard to prevent. Okay, so our team is called WeldWise AI. Our solution consists of multi-modular model that's going to be able to automate a 60-degree freedom robot arm. There are currently a lot of companies in the industry who are working on the same problems, who are trying to make a fully autonomous welding machine. The problem is that a lot of the companies have one aspect of that and not the others. And the system itself, like the first automated robot arm was invented in 1960, and it's capable of performing welds in a circular motion. That kind of approach, first of all, it assumes perfect conditions of the welds. Second of all, a lot of the systems are very rigid, so they're not capable of adapting to different alloys, different types of welds, and the environmental conditions. So if you look at the schematic, you can have your welding system, you can have sensors that are going to collect the information from the welding machine, as well as the camera and the X-ray camera. All of that information is going to feed into the data hub that has the ML model. And you're going to have an UV server that's going to display all of that information for the staff members to see. And then you have a control module that's going to extract the parameters from the ML machine and then constantly modify the robot to improve the quality. And then for the model itself, what you have is that you can collect the information from the cameras, again, from the sensors. You have to stack it up in early fusion. Then it's going to go through the CNN layers. It's going to extract all of those features that you want to have. Is going to be able to recognize the quality of the welds and then give it a score. And then all of that is going to have to go into a different model, the neural MPC model, essentially to be able to control it and for the model to consistently improve.
So we've prepared a video demo of the machine learning model that I and Nathan Wang developed together. My name's Alex Santa, and this is a quick demo showing what we came up with to demo today for you all.
Hi there, everyone. My name is Alex Santa. I am a fourth-year computer science student, and I was in charge of the back-end machine learning aspect of this project. I developed a YOLO V8 model that is capable of looking at pictures of welds and labeling them as good, bad, or defective. It is a straightforward model, and it is the foundational piece of what we will develop to be an automated welding system that will. Thank you so much for your time. This is some brief scroll through of the code, how we trained it, and the architecture itself.
Hi, my name is Nathan Wang, and I was the one responsible for developing the front-end side for our project here. So with this dashboard, we are able to keep track of all the devices and to edit and to view all the data pertaining to it. So on the right, we have the devices themselves, and if we go ahead and select one of them, this one is currently welding, and right here is the information that has to do with the weld itself. This is important information that will ensure the quality of the weld. Now, another way we can ensure the quality of the weld is by using the convolutional neural network that Alex has developed for us. And so to demonstrate how it works, we can simply input an image here, and it'll go through the model, and it will tell us whether the weld is good or not. Now, here's another example, and one more example for good measure. And there we go. Thank you.
Hi, everyone. Thank you, coders. I'll take it from here. So I am a supply chain major, and my team told me to make it more scalable and affordable. So yes, welcome to the business world. Here we have cost. So we have sensors, cameras, prototype cost, the scale cost, and we are going to source all the materials from different countries like Germany, China, India, Mexico. Our delivery would be 30 days by the sea route. What metrics we bring on the table is the energy we're going to save by 20%, waste by 30%, and labor by 50%. This market is a $20 billion industry, and it's growing 10% every year. Who are we targeting? Our industries will be automotive, aerospace, heavy machinery, and construction. We have 2 experts coming up to us for this project, and we are gaining momentum. It's going to transfer to research, development, universities, laboratories for new welding technologies. What's for the future? It's predictive maintenance. It's going to help to track the equipment's wear and tear and prevent the failures. Material learning. System improves as it encounters new alloys and weld configurations. Data sharing, most critical. It's going to improve the consistency worldwide. And finally, honoring the traditions will make sure the knowledge of generations continues to thrive in this modern tech world. Judges, this is a game changer. It's going to save life, cost, and the industry. Let's scale it together. Thank you.
Hey guys, great job. I don't know a ton about welding, but my brother does, and I'm definitely going to tell him about this later. Just a quick clarifying question. I think the answer is yes, but I'd just like to hear it from you guys. Are you guys selling the technology to existing weld robots, or are you wanting to introduce a weld robot of your own with the technology implemented?
So that would be, we would have to sell the robot as well, because we're also going to, the way that you would set up the system, we would have to reinvent it, yeah.
Thank you.
So yeah, I haven't done a lot of welding, but I do race cars, and I know that there's a lot of welding involved in keeping a car together. But I think of the larger practical applications that the industry, such as shipbuilding and other, is this scalable up to larger applications, or is this really designed for sort of modular, production lines like car building?
Yeah, so because it's a modular model, you can totally scale it up to different industry sizes. But then for bigger industries, I would say it's more of mechanical problem, because you already have, for example, spot welding. It's fully automated. You have, for example, 2 sheets just traveling on the conveyor belt, and the robot arm automatically spots it. Yeah, so with this model, you can make it work with that system as well, but it's more of like mechanical problem than
so
software.
the aspect of validating the integrity of a weld, is that separate to the actual welding itself? Could you take the accuracy piece separate it and use that for for another industry?
Oh yeah, 100%.
Okay.
Yeah, you have some layers to extract, for example, kind of like the path detection to recognize the environment, and then other layers are going to be responsible for doing like the image detection, as in the case like the quality of the weld itself. Yeah.
Thank you.
Oh, you have another question.
Just one quick question, and maybe we can talk during break. How did you come up with this idea? Because I've never, it's pretty crazy and awesome. And my son actually is in sheet metal, so yeah. I'm going to talk to him about this tonight. But where did it come from?
So I'm a mechanical engineering major, so I had to take a welding class, or not a welding class specifically, but like kind of manufacturing class where I learned a little bit about welding. I already knew about all the problems that exist in the industries, so the next step was just like, okay, like how would you solve it with AI? Okay, automatic robot, here you are.
Okay, very good, thank you so much.